Okay, now members, we are going to see how do we apply logarithms in these numbers. You can apply it in multiplying numbers when you are dividing numbers and when we are getting the roots of numbers, or when we are getting their squares and their cubes, as we are going to see. Okay, so let us see how we handle these ones. So they give you all numbers first of all should be in a standard form. If they are not, then you convert them to standard form. Okay, use logarithms to evaluate the following. They first give you this. Now it means that, first of all, you know that if you are multiplying, it means that we are adding in logarithms. What happens now? They are not in the standard form. In standard form, we mean they dig it before the decimal point should be between 1 and 10. So it's that now we shift this. Get this to standard form. We said if we shift to the right, we get a negative. If we shift to the left, the power should be positive. And this one indicates the number of places we have moved. So this one now I said 1, 2. I'll push it to here, then times 10 power 2. And then if we are to read this, we say write this 2 first, then read the logarithm of this. The logarithm of this, you write this 2 first, then read the logarithm of that. If I get my table, read that logarithm as you see here, my table is going to be, what I have done now to read is 3.5 and 6. So when I read my table, you come and you look at this. When you see this table, we are reading 3.5, so it will be 3.5 here, then under 6. Under 6. I think you see under 6. It's there. By under 6, you see the value 5514. But we said all these figures here are 0.0 here. That's why when we add it 2 plus 0.551, this is what we get. So these two plus now what we have read. This one here was 0.5514. When we add it to 2, this is what we get. Then plus now the standard form of this. So this one is shifting one place only. So times 10 power 1. We are shifting one place. Here we use the 1, 2. That's why we have 2. Here we have 1. Then read this one 4.36. So first of all, this power comes here. Then plus what we read when we have to read this from the table. It's 4.36. So 4.3. I think we see 4.3. It's going to be here. 4.3. Now under 6, you see it's here, under 6. You see the value is there, this one here, 6395. So this is now 0.6395. Then you add this one. When you add this one, that's why you get this. Now from here, we add this and this. Why? Because when we are multiplying, we add. When we are dividing, we subtract. So this, because we are multiplying, we shall add. We add this, we get this. Then after getting this value, you get its antilog. So the antilog will be equal to the value when you multiply this and this, we multiply this and this. So the antilog of this, we said you start by separating this from this. So this will be 4 plus, now this will be 0. This. So we add this instead, we get back that. Then this, then the antilog of 0.1909. So mine here, let me show you how I read mine. 0.19. So in antilog 0.19, you look at mine 0.19. 0.19. We read it. First read 1.9, which is there. Then you see it's under 0, which is this. Then we are adding under 9. So under 9, when you come here, under 9, we are adding a 3. So when you add this 3 to this value here, you'll get 1.552. Then we say that these ones at 1 point. So the other one, for logarithms, they are 0 point. For these ones, they are always the first figure point. So now this will be now 1 point. It will be now 1.552. We added we added under 9 to 3, then we read off this one, 0.19, then when we add the 3, we get, with this one we get 155, but we say it's 1 point. And we get this and this, that's what we get there. Okay, the same idea here, we are multiplying by this one, we convert it to significant figures, I mean to a standard form. This will be 1, 2. But now I'm moving to the right, that's why this power is negative. I'm moving to places 1, 2. Then this one, I move down to the left to 1, 2. For it, it's positive, but I'm moving 2. We read this from the table. This 2, negative, we write it first, then plus what we read from the table of logarithm. When we read this from logarithm, we get this. Then also this, we write this 2 first. Now when it's negative, write it as 2 back. If it's positive, write it as 2. That's why then we read this from the table. 3.2 under 8, you get 0.5159. When you add it 2, then you get this. Then the analog of this is what we read. When you read the analog of this, you will read 0.91 under 7, then you add a figure and a 3 in that row. This is what you get. Now when you count roots, you know that they give you a cube root of this. A cube root is the same as a third. A square root is the same as a half, like that. Now, you first convert it to a standard form. Then you shift this one. Then you get this one, you write it first. Then you read this from the log table. Or you press log of this. When you press log of this, you get 0.2119. Then plus this one. So you press this, then you plus this one. That's what we've been doing. This plus this 2, that's what we get there. Then when you bring in this cube root, then it's the same as our third. You multiply with what you put here. So this one is going to affect this by multiplying it. So this is our third times this. Then you get that. Whenever you have a power, you just multiply that power. If it's a square, you multiply here with a half. If it's a cube root, like we have done. A fourth root, like that. Then the antelope, then after I read the antelope, this antelope when you read the orange will be the value of this. That's why now the value of this, which is our cube root. Now the cube root of 16.29 will be that. When you read, when we get the antelope of what you got here, will be the value of what you are calculating. When you come now to this one is a cube. It's not in the standard form, so you first shift 1, 2. So you get this. It goes here, but you are moving to the left, the power is negative. Because whenever you move to the right, the power is negative. Then write this 2 first. Then you go in the table and read 4.23. Then after the value we get, we add this. This is what we get. The value we read here, 4.23 is 0.263. Then you add this, that's when you get this. Now, the power now is 3. Now you just get and multiply with this. But you say, in multiplication, if the characteristic is negative, then there we separate first. So separate this and this, the characteristic from the answer. When you multiply this and this, you get negative 6. When you multiply this and this, you get this. Then you add this to this. When you add a characteristic to a characteristic, you get 1 plus negative 5, you get negative 5. Then this plus this, 0 plus this, you get this. Then this is what you get after multiplying that. We cannot multiply directly. Whenever you multiply, this works. If it's positive, it's okay. You can multiply the way you want. But if it's negative, like we said, negative is too bad. You first separate the answer and the characteristic, then you multiply them separate. After that, then you add them. That's what we've done there. Then the analog, this we say you separate, then this power this, 10, then this power 10 power this. When you read this, you get this from the table. When you read this, the analog of this is this, then this is here. And now when you press this, you get that. Now when we are dividing, still, you check, are they in significant form? In standard form? No. So now you convert them. This one you are going to shift to 1. The number, standard form, then the logarithm. The table is having 3 columns. Then you shift this one. We have this now times 10 power 1. Then this one we are shifting 1, 2. But now we are going to the right. The power is going to be negative. When you are going to the left, like this, the power is positive. Get this one. Then read off this, we got 1553. When read 4.43 in the table, you get 1553. When you add on this one, then you get this. Then remember this one, now we write this 2, negative 2. We said negative 2 is the same as 2 bar in logarithms. Then when you read 1.7, you get 0.2304. When you add this negative 2, that's what you get. But if you are dividing logarithm, it means we are subtracting. So you subtract here. Now be careful when you are subtracting here. This one we borrowed here, 13 minus 4, you get 9. This now we borrowed, so this is 4 minus 0, you get 4. 5 minus 3, get 2. 1 minus this, we cannot. So we borrow here 1. But when we borrow here, we shall be here, it will be 0. Then this will be 11 minus 2, which is 9. Now here we remain with the 0. 0 minus, remember, 2 by is negative. So we have 0 minus 2, which will be a 2. This back here, that's why we have it there. Then after read the envelope of that, we write this 2 power 10 don't diagonals, the remainder, this one, the answer. The envelope of the answer. Then this is 100 diagonals. When you read this from the envelope table, you get this one, you multiply, that's what you get. And now check your answer. You make sure that when you multiply this one, or I mean when you divide them, the answer is close to that. Here, if you use a calculator and just give us the answer from here and you give us the answer, you get 0 from 0. These numbers are taken at least 4 marks. I wish you well.